right, so today we've got a great treat for you guys. I'm here with Obinna Igbokwe, a top enterprise architect, creator of ZenHey, which is a digital platform that does all kinds of amazing things with transforming data. I think you can try. What's your record that you have now for how many records you can transmit?
Well, we're at somewhere around 300,000 a minute.
So 200,000 records a minute, right? So obviously, a person like this is gonna understand and know about moving lots of data, moving lots of transactions. So in this episode of Architect Roulette, off camera, Obi drew X, or formerly known as Twitter.
Right.
So he's gonna be telling us, if he were building Twitter, how he would set it up and how he thinks Twitter works in the nitty gritty. So with that being said, tune in. So Obi, we're gonna be talking about Twitter,
Right.
and how you would build it, how you think it's built, how do you think it's possible? So without thinking of technology, just pure architecture, right? If you were gonna design a system that was this distributed, that can handle all those different things, you wanna draw up on the board how you might wanna do it, what you might wanna do?
All right. So let's look at it from left to right. So I'm going to start over here.
Okay.
I'm going to work my way over to that side.
Mm-hmm.
So entry point is going to be users. So we're going to have a user that's coming in. I don't know who that user is. It could be any user that's signed up for Twitter. So we assume that that's a registered user that's coming to our system. And then we need a way for our user, who's registered by the way, to be able to communicate with all our backend systems. Now we don't know where our backend system exists, but we need to be able to expose it. So this is the first thing we need to talk about is how do we allow information from our user to enter into our system? That's the first question, right? And what options do we have today if we look at the current technology, right? So there's a concept called endpoints. Endpoints is basically it's just an exposure point inside of our application that allows us to push what we call data. So the question is that this user is going to send us some data, right? Now we have to agree on the type of data that's going to be received by this user to be put into our backend system. So that's the step one, right? Mm-hmm. And there are two formats today that are being used in technology today. We have XML, which has basically been around for a very long time, and then we have JSON. So that's the first thing you got to agree on. So you have to agree on the type of messaging format you're going to use before you start building out any kind of technology platform to actually ingest that data. So whether you're going to cloud, whether you're on-prem, it doesn't matter where you are, you have to choose the messaging format. Now, normally when you decide that you want to choose a messaging format, the next thing you have to agree on is the representation of that data. So for example, what's the structure going to look like? Is it going to be structured or is it going to be unstructured? Now, JSON comes with two flavors. You can have JSON as unstructured. And, here
you go.
Get us spelling. You know what, I'll just keep here. So you have unstructured data, sorry with my handwriting here, and they have the structured data. Now, if anybody understands how unstructured data basically can come in as a payload, and there's no schema attached to that. And if you know what a schema is just a way of representing how the data is going to look. So the schema is almost like how we define the schema. So the schema is almost like how
it's like the rules
or the representation is supposed to look like. So this has no schema. So if you're sending in data and we don't understand the way your schema looks like, we consider that unstructured data. Now, if you know what the schema looks like, right, we know that that data is considered structured. And the reason why I say it's structured is because we can then decide how we're going to store the data. Now, structured data normally plays well with databases that have relational databases. And a good example of a relational database is a SQL database. Now, it could be Postgres, it could be Azure SQL database. So it could be Azure, or it could be, in this case, just be a SQL database. Let's call it SQL DB. And that's how we define structured data. Now, the solution that we're trying to present today is going to be capable of taking in unstructured data, which has no schema, and structured data, which has a schema. The catch is that we're going to produce an endpoint that will allow the users to be able to take these two pieces of information, and then we have to decide how we're going to store the data into our backend system. And that's the goal that we're trying to accomplish. Now, what does a chat application typically have? One, you need a registration. So you need to register the user. So you have to register the user. And then once the user is registered, they will go through what they call an MFA, which is a multi-factor. So we just call it MFA. And everybody's comfortable with MFA now. That means you get a message on your phone. You can get it either as a text. In this case, mostly text. Then once you confirm the text, you can actually go back to the MFA process and you come right in here. Now you're logged in. So now you're logged in. And in this case, we're logged into a version of Twitter, right? In that case, we're going to call it our version of Twitter. And then once you've logged into the system here, now you can start building your messages or communicate with groups. And this is where we have to take into consideration when there's a lot of chat going on. So we call this almost like a system that allows you to communicate with different parties in the group. So a group of people, a group of users that you can communicate with. You, like any other system, you have members in your group, and anytime you send a message to your group, everybody else gets it. So it's basically a collaborative solution that we're trying to build out here. And that's the key thing here. This has a lot of messages. So we can, by default, have a blocking solution that prevents you from sending messages. So we don't have, normally a typical solution would allow a user to send a message to a backend system and wait for acknowledgements. But when you build a chat application, because there's so many messages being sent out, we have to send the messages to our backend system, and then we have to return back with an acknowledgement, and then the message gets put into a system that it can be separated and put into a backend database. So how do we build a distributed architecture? That's basically what we're trying to get to, right? So what's distributed architecture or service-oriented architecture, where we have to build out multiple components? The idea is that we have to build one system, and then we're going to what we call distribute loads to other systems to handle that. Now we're getting into the technology space now. So we've talked about what the ask is here. The next question is, how do we build it out? All right, so just to summarize, a user logs into our system, they register in our system, and then when they try to authenticate, they're challenged with this login process here. They're challenged with the MFA, they get the text, they log into our system. Now they're in a version of our Twitter version, right? And now they want to begin to start using it. And we're going to assume that this user, after they've logged in, 6 months has gone by, and they've actually got maybe 300-400 members in their group, and they want to communicate. So they start putting pictures up there, they start sharing videos, they start sharing text messages, correspondence back and forth in the chat. So the question is, how do we build a system that can handle images, handle images, handle media, as well as text in one system? How do we do that? So a couple of, we've been discussing, and we decided that we're going to put everything inside of cloud. We've decided we come up with Azure as being the cloud platform we have. Now, there's a couple of Azure cloud platforms out there. We have AWS, which is owned by Amazon, and then we have GCP. You hear that term, which is owned by Google, and then we have, in our favor, we have Microsoft. In this case, we have Azure, which is owned by Microsoft, right? And because we are more on the Microsoft side of the house, expertise on the Microsoft side of the house, we've chosen to go with this option. Now, a lot of these two options are still great. They will do exactly the same as this one here, but we've chosen to go with Microsoft. And because we've looked at the use case, we've decided that everything that we're going to build out is available inside of the Microsoft Cloud solution. So the first thing we're going to talk about is users. What does the user need to be able to send information into the backend system, right? we need an endpoint. And we heard me talk about this, how does data, user become data, requires what we call an endpoint, right? And an endpoint in technology terms is just a place to expose how we're going to receive data. The problem in the so we're looking at marketing and say, what service do we need that would satisfy an endpoint that allows us to collect data? And after some discussions with the team, we decided we're going to go with an Azure function, which is what we're going to do here. So here I'm going to put Azure function. Oh, excuse my writing here. And Azure function is going to handle our data coming in to our system. So this data in is going to be used for Azure, and so it's an Azure function, and now and to support both XML and JSON. So we satisfy the ask in terms of the messaging format that's coming to our system. The next question is that how do we support images? Now this is where it gets interesting. An Azure function, I don't want to get too much into detail. Azure function has multiple ways of receiving data. They can receive data as messages. They can also receive data as pictures. Oh, sorry. Receive data as pictures. So images, we can get images. And we can receive, depending on the size of the media, we have to cap the size of the media at a certain amount. Now, recommendations is when we chose to use an Azure function to receive media, we want to keep our media sizes maybe within 2 to 3 minutes. What's the YouTube shorts? Maybe it's about 5 minutes or 6 minutes, and that will give us somewhere around maybe around 50 or 60 megs or something like that, right? So we just say let's just cut it off at 50 meg, right?
So this Azure function, when this data in you're talking about, this is all HTTP based?
Yes, so this is all HTTP. I don't want to get into all the HTTP stuff, but the goal is that it is HTTP based, which allows us to accept JSON, this thing, and then images are going to be obviously going to be binary, as well as the media is going to be binary. It's just some of the types are getting received. So these images and media are just type based, and that will be written to some way. So now we know we're getting data coming in. And now we know we're getting images coming in, and now we know we have media coming in. We've satisfied our system of how we're getting the three types of inputs we're going to be accepting from our HTTP endpoint. The second thing is storage, where we're going to put it. So when we receive images, we need to figure out where we're going to store this images and media. So we've decided to go with another solution in Azure called Azure Storage. Right? And again, Azure Storage is basically similar to, if you're on-prem, you have what they call a NAS, where you can store files. Azure Storage has a lot more than just storing information. Now, Azure Storage is going to be used to store files. In this case, we're talking about images and media, right? They also have an option for, I'll talk about this later on, but they have other options for queues. And if you have time, we'll go into that later on. Sure, I get this right in my race right. We have queues. Oops, I'm messing up. Queues. This big queues.
UE.
Yeah, I know queues.
UE.
Yeah, I always get it right. Yeah, queues. And then we have files, queues, and when we have storage, table storage. I call it NoSQL SQL table, and we're going to leverage that today for our solution. And then we have blobs. Now, blobs we'll talk about later on, but blobs basically is a file. It's similar to files, but they have events attached to them. And what the event is that when I drop a file into a blob, then the event that's sent off to let whoever's listening to be able to pick this file up. So that's the difference between these. Files is basically doesn't do anything. You can put images and media in there, but if you're using a blob, then you have to have an event attached to that, and you have someone else listening to pick that information up. So now we have storage taken care of. Now the other thing that we need to look at is the structured data. So we have the structured data. We want to be able to build a solution for that. And we've looked at all the different options, and we decided to go with an Azure SQL database. So we'll go Azure SQL DB. And this is for our structured data. So the structured data goes into Azure SQL DB, and we should have a schema attached to that. So this is for our structured data, right? And we're going to build what we call tables out of this. They will have schemas attached to that. So these tables are going to have a schema. So there's some knowledge of what information is being collected when we register a user. So we already have that information. So we have just assumption, we have an intake form, whether it's on a mobile device or whether it's on the website. And that process will actually define what the request representation will look like when we do a data in. We already have a schema attached to that to validate the schema is correct. And when that flows down to this section here, we'll have a table that represents how that request comes into our payload. So we got that taken care of. The other part is the structured schema. Now the structured schema is interesting because this guy here is a very good solution because it allows us to put our unstructured data into here. So we can say this is unstructured, right? So when we receive data that we don't understand the schema, we have a home for that. And when we receive data that we do understand the schema, we have the Azure SQL table for that. The other thing that we have to take into consideration is now the user is logged into the system. They've signed up, and then maybe they have like 300, 400, 500 members. Remember, there's going to be thousands of people coming into the system, and probably they have the same number of members as well, and they'll be sharing a lot of information. So this is going to be where we have our chats, right? So we have our chat going on here. There's going to be a lot of in and out coming out here, so we need to collect the messages as quickly as possible, put them onto something that we don't necessarily have to wait for an acknowledgement back, meaning a request response, and we can do a find and forget, but we need to be able to track all our chat messages, right? So we chose to use an Azure service called an Azure Service Bus, right? And every one of these services have a specific purpose in our solution. This solution here handles just messages that are coming out from our chat. And the reason why we're using a service bus because a service bus allows us to do what we call distributed compute. We can actually send messages to a centralized system, and then we'll have multiple subscribers picking the information up at different. So what we call a publisher subscriber solution. This is a publisher, so the chat is basically a publisher. Now, and we have to build the consumer side of the house to solve that problem. So what I did here, which I'm going to add another thing, this is this guy here. So remember, we chose the three. We have 1, 2, 3, 4 resources in Azure so far. But we're trying to expand the capability of every single resource that we have here. So to satisfy the consumer side of this, because this is the publisher here, and then we're going to have we're going to go all the way here, put the data somewhere here. Then we have a consumer who has to consume this thing and put it into 1 or 2 databases, NoSQL or SQL database at a later date. So this is what we call, the publisher subscriber part is what we call eventual consistency, where we publish to a central repository somewhere here, and then we have a consumer pulling the messages up as quickly as possible. Normally the publisher subscriber solution, we have the publishing of the messages are much quicker than the consumption of the message. That's just why we work with a solution like that, because we don't want to have any delay when people are sending chat to our backend system. So these consumers again are going to be part of an Azure function. This is where it gets interesting. This is where Azure functions become very important, because Azure functions now do multiple things. They can actually consume XML, JSON, they can store images, they can put media, and also they can be consumers of their own messages. So think about it this way: a message comes in, chat is always mostly messages. We've already talked about the different formats, and we know we're going to store it in a SQL database, and there's a consumer here, which is the same Azure function, and that's going to take the same messages that we have here, and it's going to be listening to the messages and put them back in our database. So that's how we solve that problem. So now we have the solution that allows us to publish multiple messages and put in here. The service bus here, the service bus here is to create the mechanism that allows us to publish and consume the messages. So this is where the distribution comes in. So the service bus has 2 functionalities. It has what we call a queue and a topic. Now this is different from a queue instead of a storage account. This is more of an enterprise level queue that we're used to on-prem. This is more just to manage how the files are getting distributed into applications. And the reason why there's queues instead of storage accounts is that imagine if we have tens of thousands of files coming in here and there's somebody different processing it. Or in this case, I'm sorry, it's mostly for blobs because blob file have events. And normally where we have more blobs that are coming in and the events are getting sent out, there has to be, if there's queuing up, they want to be able to put the number of events into a queue. And then as the queue goes down, and the notifications get cleared up, the queue gets emptied out automatically. So this is basically an internal queue. We don't really subscribe to that. In the Azure Service Bus, we have to subscribe to that, right? So when you create a queue, or in this case, what we call a topic. Now I'm going to talk about this independently, right? So a queue is a one in, one out, meaning that you can only have one publisher, and you have one consumer. You can have multiple consumers on a queue. What does that mean? That means that if all my data, I have to decide ahead of time where all my data is going to live. Is it going to come into a SQL database or is it going to go into a NoSQL database? But the solution we're presenting today allows us to be able to send data to a SQL and a NoSQL database. So we present that solution because we don't know what kind of messages they're going to be sending us. So we've chosen to go with a topic which allows us to send one publisher, and they can fan out to multiple consumers. So what we can think about here, this solution here, is that the consumer, get this, let me do this right, get this right. So we have the consumer one going to NoSQL, and we have another consumer going to our SQL database, right? So SQL, DB. So now we have a solution that accommodates for both of that. Now, how do we determine?
One question.
Yeah.
Why wouldn't an application? Can you talk a little bit about why an application wouldn't just go straight from the interface directly to the database? What are the limitations? Why do we have to use a topic in this case, or a queue? Is it because of load? Is it because the database would be very slow if you're just publishing directly into it?
Right. No, the reason why we would decide to, first of all, the reason why we would tightly couple our user interface into our database is because one of the things we have to take into consideration is that we have a team that's going to be working on this. So we want to be able to do isolation testing. So testing is very key. So if I build my UI and I build my database and we have a direct connection to the database, there's no way to test them in isolation. Okay. That's step one. Step two, there's no way to white label. I don't use the word like, but white label lightly. Supposing we wanted to build Twitter as one application, but supposing we wanted to build another application that uses similar to Twitter. So for a good example is that Facebook and Twitter have a lot of features. They do have members, they have groups to share information. Even Instagram is similar to that. There's some variances in all these applications, but the bottom line is they all kind of do the same thing, right? So imagine if you wanted to build a solution that allows you to integrate into Twitter, that tomorrow you have another solution that integrates something else. There's no way to actually disconnect your solution to your backend. So we want to have a separation. And then load is the next thing we talk about, right? If I'm sending a lot of data into a chat system, which is basically a very chatty system, and you want to connect to your SQL database, you have to wait for an acknowledgement to come back before you can move on and do something else. So it's going to be a request response. What a publisher subscriber solution allows you to do is allows you to just publish messages in a one directional manner. So I publish from here to here and again acknowledgement back. I don't necessarily have to wait for this guy to respond back. There's no acknowledgement from the backend system. And this system can publish at a different pace. So I can be sending data here twice as fast as sending it to the backend system. The consumer can be processing it half as fast, but you don't lose any performance on this end.
You don't lose any messages.
No messages are meant. So this is a durable solution. And this allows you to do replays. And it will let me write this correctly. The solution we're presenting allows you to replay messages. It has a capacity of 1 to 5 gig, which is what and it will hold data up to 1 to 5 gig. So meaning that if messages are being sent to this system and we suddenly have a disconnect here between our backend systems, guess what? The messages are going to be still inside of our system over here. Let me read this properly because I don't want to get this out here. This is called replay. So I have this, even though my handwriting is terrible on this thing, the damn thing, it loses. So here we have, so the idea is that we can store replay here. So if anything happens to any messages here, we have durability, and then the messages are stored in the sequence in which they're put onto the service bus. That's one of the most important things. So it's a first in, first out. So whoever gets into the messages first, it doesn't know how many are going in. They will tag, everything is tagged in the numbering system in the order in which it was received. And the consumer will consume in the order in which it was put onto the service bus. So you're not going to lose any ordering of your system. That's why we recommend going with our solution. And that's one thing. And if there's a faulty message that cannot be processed inside of a SQL or a NoSQL, just because data might have some, it might not be, assuming that someone sent in text in some JSON and we go here and these two guys doesn't understand the messaging format, that message will go into what we call a dead letter. And I don't want to go too much. The dead letter basically is a place where you keep anything that cannot be processed. And then that gives you the opportunity to go and inspect the message, and then you can replay the message if needed, or you get rid of it. So there's a lot of benefits here of doing that. And if we chose the solution that is in Azure, we have an opportunity to monitor how messages are moving across the system. Why? Because you want to understand where you have performance bottlenecks. So you're constantly monitoring how data is moving into your system, and then you can elastically grow to accommodate how much data is coming into your backend system. So a lot of benefits there. And the last piece we talked about is you can do isolated testing, meaning that I don't necessarily have to wait for this system to build. I can just test my system independently to satisfy the business need. Then when this gets built out, whether it's a Windows platform, whether it's a mobile platform, that will just get bolted into the back end and we're good to go. So some benefits there. And the last piece that I was going to say is that we don't have to worry about networking. Now, networking is something that you will get into this space when you get to the cloud, because most applications today, if you have to tie it directly into a backend system, then you're going to have a lot of networking issues because they have to open up ports. This is a user solution, so we don't want to get into having to open up firewall connections for individuals. So that's the reason why we connect to an API. And the API is the person that has access into the backend system. So we keep everything very clean by doing things that way. So that's kind of, does that answer your question?
Absolutely.
All right, so now we have Azure Functions, we have Azure Storage, we have Azure SQL, we have Azure Service. We've ran that with our team, and they agree that these are the services we're going to use. The one thing that we have to add to this mix is everything we put in Azure has to be monitored. There has to be exposure points into this system. How do we, if a function is breaking down, or a storage account is breaking down, or a SQL data is breaking down, how do we know which independent system is breaking down? So there has to be a guy that's going to monitor this. So then the one last thing we're going to introduce is a thing called, I'm going to put a box around this so we can understand this completely. All this is going to be monitored by a thing called, believe it or not, called Azure Monitor. That's why I love Azure. It will tell you exactly what it is. There's no magic here. Azure Monitor is Azure Monitor. Azure Monitor is going to monitor everything in the system. When you choose to go with this ecosystem, this comes for free. Not necessarily for free, but it comes as a plugin. So by default, when you configure this, all we have to do is ship all our data. So this is the logs that come out from all this system will go to another system called Azure Log Analytics. And this is how our business over here, let me draw the business here, has what we call insights into all our resources in here. So this is the connecting dot. Monitor looks at all our systems, and if there's anything that's wrong with that system, it will send alerts or email or text to whoever is responsible for managing this. So this is going to be like a NOC, network operating center, is going to handle that. Or it might, in this case, this information will all go to what we call a NOC. NOC is Network Operating Center, and they will get their alerts. And guess what they do? The NOC comes over here and says, okay, let's look at the insights, look at business insights, see what's going on with all our systems, because these are all the systems that the business cares about, and based on the Azure analytics, they can actually deduce what's going on, if there's exceptions, there's a performance, if things are not working right. This guy here handles all that capability, and we can run reports of this guy. Now, another thing you can run off here, which I don't want to get into, is there's a thing called Power BI. Now, you hear that term a lot, Power BI. Power BI has direct access to log analytics. So imagine the business comes in tomorrow and say, hey, we built this beautiful system, we're a year in, we want to understand the behavior of our system to see whether we can introduce more users. Tell me what our performance looks like. The Power BI guy doesn't even have to come into Azure because this is exposed directly to an API or endpoints, and then you can actually start producing reports in real time and surfacing that to the business. The next thing we're going to do is we're going to connect all the different resources that we just talked about. So the first resource we're going to talk about is an Azure function, right? So Azure function. And the next resource we're going to talk about is what this Azure function is. So this is a sequence diagram. So we're going to show all the activities that are going to be happening through this life cycle of this function. So we're going to have so Azure function by itself is produces what we call a HTTP. You heard that conversation earlier on. We have a REST. This is going to be a REST service. So I'm going to draw another box and just represent it as a REST service. So RES service, and that's what's going to produce our endpoints. So this is going to produce our endpoints here. This is our endpoints, and we already talked about the different message formats we're going to have. So this is another guy here that we're going to talk to. And then the next we're going to talk to is that this guy is going to have communication with two things. This is going to, let me see what that works first before I start. Yeah, that's right.
Perfect.
So this is endpoints. It's going to support our endpoints. That's just better, right?
Yeah.
A lot better.
Yeah.
Shit. Exactly. I used this in the first place. That was trash. So this is endpoints. And then we have another one here, which is our storage. So this is going to be our storage. This is going to be Azure storage. Then we're going to have another service here, which is going to handle our service bus. And then we're going to have another box here, and I'll connect all this together. We're going to have Azure SQL. And then we're going to have a NoSQL database. So SQL databases. And all these are going to be connected. We're going to draw a flow on how this is going to connect to each other when we're done. So user comes in. This is the first entry point into the system.
Can you highlight that? Just draw over that with the black ink.
Oh, okay. Won't you square it off?
Yeah, just so we can kind of see
Yeah.
what all the parts are.
Okay, so we have a service.
There you go. Yep.
All right. So and then let me re-emphasize this line.
Thank you.
Try it right now. So this is our entry point. This is basically our start. User comes in. Let's put the user over here. They come into our system. They make a call into our backend system. Now that includes registration, authentication, let's say login, and chat. So this is where everything's going to come in through. So all the messaging is going to come in through our REST service, which is a HTTP, for those who didn't know. S meaning secure endpoint. So if you go to your browser, HTTP is what we're doing. So basically this is going to be in our HTTP REST point, HTTP endpoint. Once this registration login or chat comes in, any messages that come in as files, so we're going to get media files, we go on media files, or images are going to be stored in a SQL database, right? In our Azure storage. So we have files and media that's going to be going into our storage, right? Messages are going to hit the same API, but guess where they're going to be going? They're going to go to our service bus. Then there's going to be an acknowledgement. I'm putting this in dots because we're going to get an acknowledgement that comes all the way back to our user. So this is going to be, so immediately we started here, we're going to have a user. And then the messages here, we're going to have actually no, I forgot a step. We're going to have a I'm going to take this off. I'm going to redraw this, sorry. We're going to have consumers, take this off here. So the service bus is going to have our consumers here, which is going to be an Azure function, but it's going to be a service bus trigger. So it's going to be AZ Azure function, but it's going to be a service bus trigger.
And so by that, what you're referring to is the fact that Azure functions can not only be triggered by HTTP, but they can also be triggered by a message coming into a service bus.
Yeah, correct. So this is going to be represented here, and this function is responsible for sending messages to both backend databases. So we're going to have, like I mentioned before, we had a NoSQL, and we're going to have another one for our SQL DB. And if I draw a line down here, draw a line down here, and we can connect that. So what happens is when the user goes in here, they sign in, they put their files in the storage account. There's three processes running. There's also the data will come in. So when we have data coming in, So assuming that this comes in here, this is considered our XML path or JSON path. So it's XML or JSON that will go directly to our service bus and drop the messages in here. And that's basically what this is here. This represents, so you have the service bus drop the message in here, and then we have consumers listen to that. Now, because this is chat messages, we need to delineate, and this is all coding, we're not getting into details of coding, we need to delineate between messages that are going to go into NoSQL or our SQL database. And this is where this smart service bus becomes intelligent. Now, service bus messages do have the concept of headers, or what we call properties, or property propagation, where we take messages and we add some metadata around it, and that metadata describes where the information needs to go to. So when all messages at the end of the day go to this guy is governing how the data is going to be moved to this guy. Like if the message is unstructured, so just imagine the message is unstructured here, it comes in and it goes into our NoSQL database. But if the message is structured, and actually no, I'll put it over this side to make it much more easier. I see structured.
Unstructured.
Unstructured. It goes into our NoSQL database, and then the structured messages go to our SQL database.
What would be an example of an unstructured message that you would be receiving?
Yeah, so an unstructured message might be, they might have a free text, so the chat is going to have a free text box. You can imagine a big box in here, just free text. And then they might put things in there. We don't know what they'll put in. They might put bullet points in there. They might put anything.
JSON, RTF.
They might put anything in. So we don't want to have to force this data to have a structured representation, and we don't want to manipulate the data either. We want to keep it as is. The only thing that we're going to do is that we're going to take this information and put it as a whole into a JSON, and we just tag it, and we just put it into our system. So that way, because imagine the message can have content, can have tags associated with it, so we're going to be carrying a lot of message. Now the advantage of putting it into a NoSQL database is that later on we can do schema on read. So we can read this data later on, and then we can actually schematize it on read rather than schema it on write. So the reason why we don't do schema on write for messages on structures, but we don't want to create exceptions inside our environment. Now for the structured information, things like registration, MFA checks, anything that we know that's specific to the system that has to be structured, that goes into our SQL database, and that's what we're going to be using to index so we can get data back as soon as possible. The advantage of using a SQL database is that because it's relational, we're going to get very good performance for people that are signing up, logging in, and maybe doing anything that's related to MFA that is really structured. Now, the unstructured data allows us to keep collecting information and storing into our backend system. And that way, if we need to be able to surface that data later on, all we need is to tie in a chat ID or something or a session ID, and we use that session ID to pull all the messages that are written into our backend system.
Okay.
So now we have a solution that we can use. So now if we go from left to right one more time, we have our Azure function, which is the entry point to our system. We have REST API, which is going to be supported by HTTPS. It will be supporting registration, login, and chats. Some of the things that we agreed that we're going to put into our backend system is files and media. That's going to go into a storage account. we've decided that we're going to use, I described the storage account earlier, but it's going to use the files to store all our files and our media.
Blob storage.
Blob storage to store all our files and media. And then for XML and JSON content, we decided that we're going to put them into a service bus so we don't have any slowing down of chat messages going in, and then we can write. Then we have consumers that's going to be consuming the structured and unstructured data and putting into their respective backend databases. So now we have a solution that we can use and provide to end users. So the last piece that we're talking about is monitoring, right? So monitoring is going to live along the whole entire line. So if I put in, let me take this out. Even though it's a late box, I'm going to put it out of here. I'm going to call this Azure Monitor, right? And Azure Monitor lives across all our systems, all the way back to, let me take this out, sorry. I made a mistake here, let me just take this out from here, wipe this out. Let me do this properly. So Azure Monitor will live all the way down here across all our systems, all the way to our backend database. And every single system will register logs into our system, into our Azure Monitor. So you consider logging as a system that happens across all services along the way. I'm just repeating this so we get some kind of clarity of what this means. So log in here. I think we get the gist here. And then we have login. So we have login across all our system. Azure Monitor monitors all it, and everything is written to Azure Log Analytics workspace, which lives down here. So Log Analytics workspace, we're running out of board here, but Log Analytics workspace lives somewhere around here. So you have Azure. Sorry, I put this over here. I will just put this down here. So we have Log Analytics workspace. Oops. Workspace. And that lives here, and that talks to all these systems. All these systems. Actually, I got the arrows wrong. Let's go down right. So it goes down into all our systems here. And this goes down here. And that logs everything we have into Log Analytics workspace. And then this is where the business comes in, and the business is actually going to live somewhere here where they can actually connect to all our systems, monitor it. So we have a sequence diagram that shows how things communicate with each other. Obviously, this is a high-level diagram. We talk about registration, authentication, authorization, all that stuff is part of the process. And granular communication is also part of this process as well. So, but this is just a general idea of how we can communicate from Azure Monitor, which is overarching, monitoring everything, Function App, which is basically the entry point to our system, RESTful API, storage accounts for all our files and media, service bus for all our messages, and then we have two consumers, which is an Azure function to take all the unstructured and structured data into our SQL and NoSQL database. Then we finally have Log Analytics workspace, whose job is to monitor all the behavior of all the systems in place. And the monitor here is going to be taking care of alerts and sending out to network operating center to tell them the behavior of the system if we have any issues.
So how does you've shown here how we get data into the system, right? I've sent a message to Twitter, to this application, and it stored it in a performant way.
Right.
How does me prime, the second me, the receiver, how do they get the information now that's been put in? Like if I send a text message, it's gonna go all the way down and end up in the SQL DB. In this process, how is the person I'm sending the message to gonna be notified of the message?
Well, if you have, normally the service bus is getting so the service bus basically is where messages are going to be consumed, and if we need a recipient, you say recipient, they're going to receive it, right? Or
yeah, like how does it end up on the phone of the recipient?
Yeah, so everything goes to, so assuming that this service bus here is technically our hub for all our messages, right? So every message that we get comes into the system. So we agree that it's a disconnected system. We already have an Azure function that manages, and this is the parallel system, by the way, I've got to mention. When the messages come in here, they're parallelly sent to two separate things, and then decisions are made here which system to store it into. So it's one message, multiple consumers, and that's the reason why I chose the topic, because a good question you just asked me, how do we accommodate for acknowledgement backend? Now we can actually add, which is interesting, you can add more service bus consumers in here that can handle things like texting, maybe SMS, well actually SMS and text, let's call it the right name. So you can do either email, three forms, you have email, right? You have email, text, messages to your phone. So this can actually be another consumer. And we have other consumers that we want to add in here. We can keep building up the number of consumers that can receive the messages. So this, in return, can send messages to any device. So if your device over here could be a phone, you get acknowledgement on your phone, or you can send it back to your Twitter account itself, and you also can send messages that way. So we have multiple consumers. So the solution here is extendable. So if tomorrow now we want to introduce billing, we can introduce a billing consumer.
So so in the scenario you're describing, the recipient is a subscriber to the topic, and they're gonna get some notification in their app or whatever that says, hey, there's a message for you. Then they'll basically go back through the system and go and pull that message out, essentially, right?
Yeah. So the goal here is that when you build a JSON payload, and I'm just going to give an example of a JSON payload. I'm going to try my best here. So I'm going to have you have a send ID, which is generated with every message. So the send ID is generated at the inception of the Azure function here. And okay, let me just actually put it over here. So we have a send ID, which is generated at the beginning of the message. When the message traverses through into a file or media, because it's a registered user and has a send ID is attached to the registration, that send ID creates what we call folders underneath of here. And this is getting to all the technicalities of how we'll solve this problem. And this folder will have only information that's related to the sender ID that's associated with that. The sender ID is also attached to the messages in the headers, and I think I mentioned we can elevate properties in the messages as headers. Send ID is also here. When we get to the system here, the two things are going to happen. If the data is unstructured, you go into an unstructured database, NoSQL database with the send ID, and if it's structured, you go into the SQL database with the send ID, and that will keep track of the sender ID session. As users having conversations on chat here, the same send ID is used across all the systems. So if you want to pull all the history of that particular sender, if you give all that information through a SQL database, and you want to get into all the chat messages, we take the same send ID and go into a NoSQL database and get all the unstructured information out. And as well, that traverses the way all the way back to our files, to our media, to our folders.
So every sender ID is also a recipient ID?
Yes, same thing. So we have the sender recipient IDs, and this is where we track it. So and when we get to when we're starting to communicate with our backend system, a send ID is generated at some point during the flow of the UI, and then they track all these steps in which they're putting information into.
Okay. Yeah. So last question. How would you structure the queues or topics for the recipients? Would you have one topic for every member? How would you scale that side of it, right?
Yeah, maybe. So the publisher side of things, you can have depending on how you want it. So you might have a topic to receive all the messages. To receive all the messages, and you might have another topic to send messages to. For example, Obi wants to send a message to Edward, right? But I don't want to. I want to have a sender ID that sends it all the way to my data. I want to record the message I'm sending to Edward somewhere. So I'm going to send Edward, hello, how are you doing? My sender ID is generated. I have a topic here that says this is my sender topic.
So you'll have two topics,
yes.
one for all senders and one for all receivers.
But remember, the message that we have, this the way it gets important is that the person who you're sending it to would have in the message or the properties the user ID of that person. So I'm sending the message to you in the chat. directly, then your user ID will say, because you're already in my system and you're a member, I already have a user ID, so I'll send that message to you. So that's what we have, what we call the compensation. Then when the receiver, obviously I'll send it to a consumer, and there's a consumer that will put the message on the receiver, and then you as a receiver will receive it because you're actually as part of a consumer. So we have another one here, which is a receiver topic. Actually, subscriber, whose job is to take the message and then put it back on the receiver so the person can receive it. So it's basically a conversation.
But how does that's the key question, right? That's the critical thing is, how is the recipient or receiver notified that they have a message? Are they just gonna poll
we're going to
what would be the strategy?
So when we're using, so the good thing about Twitter and good thing about all these applications that use devices, that's what I call device IDs, is registered in the system. So when a user comes in, they log in through their device, we pick up their device ID, and then that device ID is what we use to be able to send acknowledgements to them. So when we receive it, the user ID in the system would have the user ID of Edward or Obinna, and then we'll be able to use the device ID to time to the device. But I don't know where you're logging in from. You might be logging in from a laptop, you might be logging in from a phone. We want to make sure we can send the message to the right thing. Even though you get onto systems, but if you're logged in on the phone at the time you're walking around, that device ID is what will register and push the information back to it.
So your recommendation for something like this, again, this is all hypothetical, but your recommendation would be that the devices themselves would do long polls or something.
Not necessarily, they'll do push notifications.
So you use a push notification service to push
so that's why I'm using the service bus. I mean, there's other devices, but the service bus will be able to have all the registered devices inside of it. We can do a push notification.
Okay, so you're gonna push.
Yeah, that's why we have subscribers. So you have each subscriber will have their own ID attached to it, and we can do push notification. Because topics, I didn't go into topics, has what they call in the headers. I call the headers of the topics. You can write SQL to actually pull out specific pieces of metadata, and that metadata, if it's a receiver, then you know the metadata. You have the metadata of the device ID. You can send that information to them.
But isn't there a limit to the number of subscribers you can have on a topic?
Yes, and that's the reason why you don't necessarily want to have a device you don't have one device as a consumer. You want to have a receiver that has all the device information as part of the properties of the message, not necessarily all the metadata of the message versus the message itself. So that way you can write, there's an option there to filter based on the message ID, and then you can actually send that message.
And then you're just going to use push notification service to get it to them.
Notification.
Okay, perfect.
So the assumption is that all the devices would have to be, normally when you have mobile devices, technically get registered behind the scene anyway, so you don't have to worry about that. So that solves that problem. If it's a problem, it solves that. So this is basically a kind of like a framework of how we can build a Twitter solution, a Twitter-like solution. And I don't see why this would not work. Now you got me thinking.
Awesome. It looks great. It looks great. So thank you for tuning in and watching today's awesome episode. It's a real treat. Obi's a very busy guy. It's a real treat to have him come down here and show us how this is built. If you have any ideas, if you're an architect, if you're a designer, if you're a thought leader, and you want to talk a little bit about what you do, how you do it, reach out to us. Until next time, we who are about to code, salute you.